Bismillah ar-Rahman ar-Rahim. Chapter 10. Rotation of a rigid object about a fixed axis. So many things will make this system easy to solve and easy to apply the equations. First of all, the axis is fixed. And second of all, we are going to deal with a rigid object. A rigid object, that means we can deal with it as a center of mass concept. We can deal with the whole object as one dot. First of all, let's talk about the angular position. The angular position. To define angular position for the disk, a reference line fixed in space is chosen. A particle at point B is located at a distance r from the rotation axis through a point O. Let me summarize a lot of slides in this chapter as the following. So let us start with a circle. It has the radius r, and let's calculate the circumference of that circle. It is equal to 2 pi multiplied by r. Here, c is a distance. It's what we call usually x, just a distance. And r is also a distance of the radius of the circle. And what is 2 pi? 2 pi is nothing but an angle. And this is the relation that will explain a lot of equations or a lot of slides in this chapter. So the relation between linear displacement or linear distance and the angular distance, and we can say the angular displacement is this relation. X is equal r theta. R theta. We can I have a question here. X is the distance traveled by a reference point. That's correct. That is correct. And this reference point could be here, could be here, could be here. The last point, r, is the total distance. The middle point is the distance between the middle point and the origin, and etc., etc. So let's extrapolate this. Well, that means v, which is the derivative of x with respect with time, is the derivative. Let me just put it in 2 steps. So v, it is delta x over delta t, or it's the derivative of x with respect with t. Let's apply the same concept on theta, which is the traveled angle or the covered angle. And we can, this is theta. Well, apply the same concept. Here x is equal theta over r. We derive that, which means omega, which is the angular velocity, is equal delta theta or delta t, or the derivative of theta with respect with t, meaning v is equal the angular velocity, we call it angular velocity, we give it the symbol omega, and then multiply it by r. Well, what is the acceleration? Well, it is delta v over delta t, and it is equal the derivative. We apply the same concept, so we end up with the linear acceleration, or we call it translational acceleration, is nothing but alpha multiplied by r. And what is alpha? Alpha is the derivative of omega, or delta omega over delta t, or the derivative of omega with respect with t. This chapter, by the way, is very easy. It is the difficulty in this chapter is to connect or to transfer your knowledge from linear motion, or we call it translational motion, into angular motion. اتفضل يا عادل.
Doctor, I have a feeling that the rest of the slides will be dependent on this page, and unfortunately I didn't get this page. This is why I didn't get it.
You didn't get it? What do you mean?
I didn't understand that.
We start from here again, ya Adil. What's the circumference of a circle?
2 by L.
What 2 pi represent?
An angle.
An angle. So the relation between linear motion and angular motion is this. X is equal theta r. Do you understand this?
Yeah.
Then the rest is very easy. We just apply the same concept. So X is equal theta r, V is equal omega r, A is equal alpha r.
And alpha, which is?
It is the angular acceleration. Straight forward, it's the difficulty in this thing is that it's a new thing to call. But X displacement, theta is the angular displacement, V linear displacement or translation linear velocity or speed. We call it translational speed, and omega is angular speed multiplied by r. A is the acceleration, and alpha is the angular acceleration multiplied by r. It is related to the angle multiplied by r. Why the circumference of a circle is 2 pi r? If you believe that the circumference of a circle is 2 pi r, which is x is equal theta r, that means you have to believe in v is equal omega r and a is equal alpha r. Very straight, very basic relation. We start from a very basic thing that we learn it in grade 5 or grade 6. Circumference of a circle is 2 pi r. 2 pi is an angle, r is the radius, and the circumference is just a linear distance, a translational distance. Now, whatever we learn in the linear translational laws, we just apply the same laws, but we change from linear to angular, or from translational to angular. What else we learned before? Well, we learn, for example, that V is the integration of E dt. Well, equivalent to that, omega is the integration of alpha dt. We learn, for example, displacement is the integration of V dt. Well, theta is the integration of omega dt. We learn that omega is the integration. We just put that. What else we learn? Theta. We say it. So it's just we transfer our translational acceleration at translational velocity, translational acceleration, translational displacement. Whatever we know there, we just transfer it and apply it to angular displacement, angular velocity, and angular acceleration. So here theta is the integration of omega dt. Here alpha is equal to 0. If alpha is not equal to 0, then theta is omega plus alpha t dt. And as a result, all the laws of linear motion, we just apply the same laws. You see, all those slides are talking about the same thing, except this slide. I will come back to it in a moment. So basically, we end up with this beautiful and direct relation. Whatever we learn before, we just apply our knowledge. We have all the laws in terms of angular motion. We replace x by theta. We replace v by omega. And we replace a by alpha. Theta represents the angular displacement, exactly. Angular displacement. Omega, angular velocity, and alpha, angular acceleration. Yes, it will be on the final formula sheet. That is correct. طيب, let's go back to our slide. Velocity is a vector, so angular velocity is also vector. And how we determine it? We determine it by the right hand rule. If it is rotating like this, anti-clockwise, then angular velocity vector is pointing perpendicular away from the object, perpendicular from right to left. If it is moving clockwise, then the same rule apply, and then the angular velocity direction will point from right to left, perpendicular to the motion, because angular velocity is a vector and velocity also is a vector. Follow the thumb direction. So again, we are just repeating ourselves. Whatever you learned before, you just apply it now for the angular displacement, angular velocity, and angular acceleration. Yes, it is a very easy chapter. It's a very easy chapter if you just do this link. the link is the circumference of a circle is equal to pi r. That means x is equal theta r, a certain angle with multiplied by r, and it follows v is equal omega r, acceleration is equal alpha r. طيب, so the chapter is very easy. However, difficulties like we need to apply our information from linear into angular. So let's take the first direct example. عادل موجود.
Yes, I'm here.
يلا read يا عادل.
Bismillah. A wheel rotates with a constant angular acceleration of 3.5 radians per second squared. A. If the angular speed of the wheel is 2 radians per second at t initial equals 0, through what angular displacement does the wheel rotate in 2 seconds?
طيب, يعني this is equivalent to previously when we have x is equal x node plus v node t plus half a t square. So instead of angular acceleration, before we said the object have a linear acceleration, 3.5 meter per second square. Before, now it's radian per second square. And he gave us the wheel, if the angular speed of the wheel, so if the speed of the object is 2 meters per second at t is equal 0, through what angular displacement? Well, before he will ask you for linear displacement in 2 seconds. So very easy, very straightforward. You need just to transfer your knowledge from linear to angular based on the first simple relation. What is the circumference? Ask yourself, what is the circumference of a circle? It's 2 pi r. That means linear distance is equal theta multiplied by r. طيب, let's now change it from angular to linear. So it is theta is equal theta I plus omega I t plus half alpha t square. It is 11. Yaman, صح. It is 11. طيب, what are the information given for us? Well, the first one is the angular acceleration. يعني alpha is equal 3.5 radian per second square. طيب, what is the second information? Well, angular speed is equal to radian to omega is equal 2 radian per second. So right away, I will just write it here. So theta minus theta I, which is the total angular displacement, is equal omega I multiplied by t plus half alpha t square. Omega prime is 2. So here also we have the time is 2 seconds. 2 multiplied by 2 plus half multiplied by 3.5 multiplied by 2 square. And as Yaman, mashallah, Yaman Shatir, 11 radian. So before we will say 11 meter. It's linear. So now we say 11 radian. 11 radian. طيب, can we say it in terms of degrees instead of radian? Of course we can. Look at this. We know that 2 pi is equivalent to 360 degrees. So what is 11 radian? Just a constant, give it k for example. So k is equal 360 multiplied by 11 over 2 and then pi, which is equal 630 degree. So the answer, what is the angular displacement? Well, this is my angular displacement. Either I put it in degrees or either I put it in radian. Very straightforward, extremely easy. Whatever we use in chapter 2, I think, or chapter 3 اللي هو kinematics, we just apply it here. No, theta, because we are talking about 2 pi is equal 360. So when you have 11 pi, that means it's 630 degrees. K is just a constant. K, name it, well, name it Z, name it Y, name it X, whatever you like. It is just very simple relation. I used math from grade 9 or grade 10 or حتى يمكن grade 6. 2 pi is 360, 11 pi is whatever. طيب, let's see B. يلا يا عادل.
B. For how many revolutions has the wheel turned during this time interval?
طيب, so what is equivalent, what is he is asking? Well, he is asking the angular displacement, but now in revolution. Revolution, how many revolution? So he asked delta theta in revolution. Well, one revolution is equivalent to 2 pi. That means 11 revolution is equivalent to 11 radian. One revolution is equal to 2 pi radian. So 11 radian is equivalent to 1.75 revolution. If you want to do it in degrees, we have one revolution is equal 360 degrees. So that means 630 degree divided by 360 is equal 1.75 revolution. Very easy. We need just to adjust to the relation between linear and angular. أيوة يا عادل. C.
C. What is the angular speed of the wheel at t equal to seconds?
Exactly. What is the old question before? Well, instead of angular speed, we would ask for what is the speed. What is the speed? So previously we'll just use V final is equal V initial plus AT. Now we will use the angular, so omega final is equal omega initial plus alpha t. We put the numbers. Omega initial is 2 plus 3.5 multiplied by 2, and that is 9 radians per second. It cannot go easier than that. So here it's also explaining what we just said. Now we deal with a rigid object. A rigid object, we can deal with it as a point with a center of mass, and we deal with that point. We apply all the laws of the center of mass, all the laws of angular and linear. We deal as a point in space, and this is the center of mass of this object. Or we can study any point on that rigid object when the rigid object is moving around a fixed axis. Here the book is in love with these kind of equations. However, we just remind ourselves of the concept of the total acceleration. Here we have a rigid object moving in a circular motion. So as a result of the circular motion, we have centripetal acceleration pointing towards the center, and we have a translational acceleration because the object is moving with an angular acceleration or with a linear acceleration. And we did that before. It's just a summation of those two vectors. We know this. We covered it just 5 minutes ago. Linear acceleration is equal angular acceleration multiplied by the radius. And the radius is from this point to the origin. So all of this is r. Type, what is the centripetal acceleration? Well, centripetal acceleration, we took it before, it's v square over r, or it's r omega square. لأنه we have v is equal omega r, v square is equal omega square r square, and then centripetal acceleration is equal v square over r, so that is omega square r square over r. So we come to this result. And centripetal acceleration is r omega square. If you have a good memory, you remember in one of the videos I mentioned that centripetal acceleration is v square over r, or r omega square. And we are now just repeating the same thing. Total acceleration is equal tangential acceleration plus centripetal acceleration as vectors. This is the magnitude, and you don't need to remember this because if you start correct, you don't need to remember this equation. طيب, let's take an example. A very easy concepts. We just need to transfer from linear to angular. تفضل يا عادل.
In a typical CD player, the constant speed of the surface at the point of the laser lens system is 1.3 meters per second. A. Find the angular speed of the disk in revolutions per minute when information is being read from the innermost first track, R equal 23 millimeters, and the outermost final track, R equal 58 millimeters.
طيب هلا في الكتاب طبعا مشروح التكنولوجي هاي تبعت السي دي او تبعت الدي في دي مشروحه بالتفصيل والتفصيل الممل. بتعرفوا انتم الداتا can be represented as binary 0 and 1 0 and 1 and it is stored on the media on the CD or a DVD by zeros and ones. Now the important thing to know انه always the CD or the DVD may be different speed, but for the CD always the linear speed must be 1.3 meter per second, which means انه when we are reading at the beginning of the CD has to rotate faster than when we are reading at the end of the DVD or the CD, because the speed has to be always constant, and that also happened in the old hard disks. And now you know their hard disks are SSD. Old hard disks also have the same problem. Let's say problem يعني إنه always the linear speed has to be fixed. So when you read from the hard disk at the beginning of the hard disk has to spin a little faster than when you read from the outside of the hard disk. This is the main idea of this question. إنه linear speed is fixed. Is alpha is equal 0? It is exactly when you ask me is linear acceleration is equal 0, and the answer will say, well, we look for is the change in velocity 0. If the change in velocity is 0, then the acceleration is equal 0. So if the change in angular velocity is 0, then alpha is 0. If the change is not 0, then alpha is not 0. Okay, so now let's see the information given for us. Well, we have velocity or linear velocity or linear speed, talking about the magnitude, is equal omega I multiplied by R. So we have two R's, the innermost and the outermost, two different radii. So this is the outermost and this is the innermost. طيب. So let's now apply our mathematics. So innermost we have V is equal omega I R I, innermost radius. In our situation, as we said, this is constant. It has to stay constant because the electronics of translating linear binary information into music or sound or video or whatever, this must be always constant. So as a result, omega I has to change based on the radius where we are going to read the information. So we just do very simple math. Speed, linear speed is 1.3. The radius for the first one is what? 23 milli. And what is this value? If you use a calculator, it is 56.5 radian per second. طيب لاحظوا هو ايش طلب يا شباب؟ لا 56 مش 500. لاحظوا شو طلب اخوي. This is 23 millimeter. You need to divide by 1,000 مش divide by 100. This is not a centimeter, this is millimeter. طيب what did he ask for? He asked for revolution per minute. Revolution per minute. I will do it slowly once. Pay attention to that. If you are confused, you just listen back to the recording. So I will do it once, slowly. Pay attention. If you missed it, just review the video. طيب, we have radian. Here we have radian per second. We need to convert it into revolution per minute. Revolution per minute. So we do it on 2 steps. We do it on two steps. Radian per second. First of all, we convert it into revolution per second. So we divide over 2 pi. So this will convert it to revolution per second. So that means our angular speed or angular velocity 56.5 divided over 2 pi, which is now it is 9 revolution per second. Revolution per second. طيب, now we need to convert revolution per second to revolution per minute. So we multiply by 60. So now our angular speed is equal 9 multiplied by 60. So here it's 540 radian per minute, revolution per minute. So our omega for the inner circle, يعني the angular speed when we are reading information of the inner circle of the CD must be equal 540 revolution per minute. If you get it, that's nice. If you don't, just listen to the recording again. طيب, that is in the innermost. How about the outermost يا أستاذ? اللي هو when we are reading information here at the outermost. What should the CD, what will be the CD speed of course it will be less لأنه now we have R is more, so exactly the same step. So V is equal omega outer, R outer, and this is constant. Why constant? لأنه electronics of the CD must receive the information exactly the same while we read it in the inner circle or the outer circle or in between. So we need to adjust the angular speed to keep the linear speed constant. So that means omega outer 1.3 divided by 0.58, and it is 22 radian per second. And when you do the conversion for the outer one, it is 214 revolution per minute. Revolution per minute. So we have two information now. For the inner circle, it is 450 revolution per second. For the outer circle, it is 214 revolution per minute. So this is revolution per minute and this is revolution per minute. And it's clear that when the CD is reading the information on the outermost of the CD, the angular speed has to go down. The angular speed has to go down. So as a result, do we have angular acceleration? Of course, because angular acceleration, angular speed change from the innermost to the outermost. So we have angular acceleration. So the trick is that linear speed is constant. That's correct. That's correct. When electronics is reading from a hard disk or a CD or a DVD, the linear speed of reading the information is always fixed, and we change the angular speed of the spinning material or the spinning medium. If it is a CD or DVD or a hard disk, we change the velocity, the angular velocity, if we are reading the outermost or the innermost or in the middle. طيب يلا يا عادل اقرأ.
The maximum playing time of a standard music disc is 74 minutes and 33 seconds. How many revolutions does the disc make during that time?
اوكي. ايش يا عبد الرحمن سؤال؟ تفضل.
Doctor, I have a question regarding the linear speed.
Yes.
How is the linear speed for the outer part the same as the inner part? Because the outer part, the point travels more distance than the inner part, but they both do it in the same time.
Not in the same time. No, not in the same time. We have V is equal omega R. So when R, this is constant. When we design the equipment, this V is constant. V is constant. That means if R goes up, omega has to go down to keep R constant. So outermost R is large, so omega has to go down to keep V constant. If we are reading at the innermost, R goes down, so omega must go up to keep V constant. So time is not the same لأنه في النهاية V is equal D delta D over delta T. When delta D which is related to theta, اللي هي delta theta r. When r is different, delta theta is different, so you end up with a different time. So if the distance covered by the CD is larger, then you will need more time to achieve the same speed. So
Okay.
the time is not constant. The speed is constant. عشان هيك مثلا in the old hard disks, sometime when the read-write speed on the hard disk is averaged, because sometimes if you are in the innermost circle in the hard disk, you will read, you will need more time, or outside you need more time, depending on the position or where is your data is written on the hard disk. Speed is the same, but time depends on the position of your data. So they take the average reading speed for the hard disk. طيب هلا السؤال اللي تو قرأه أخونا عادل، أعطانا التايم. How many revolutions does this take? يعني بتعرف equivalent to what question before؟ عطانا التايم وبنعرف السبيد، بيحكي لنا find the total distance. Find the total distance, which is يعني extremely easy. So let me just erase this so we can solve our problem. Okay, so what is t? T is 74 minutes multiplied by 60 plus 33 seconds. That is the total running time of CD, which is equal to 4473 seconds. Previously, we will do x is equal x node plus v node t plus half a t square. In this problem, we do a final theta, initial theta plus omega I t plus half alpha t square. So delta theta, that is the total distance, the total angular displacement traveled by the CD. Well, here we don't know alpha, so let's use another law, because we are going to calculate alpha. We don't know alpha yet. So which one we use? Well, we can use this one. X is equal x node plus half v initial plus v final multiplied by time, because we know omega initial, we know omega final, and we know the time. Alpha we don't know it yet, we need to calculate it. So we apply omega initial plus omega final multiplied by t, يعني delta total angular displacement is equal half omega initial, or omega for the inner part is what, 56.5 radian per second. 56.5 plus what is the final when we go to the outermost, it's 22.4 radian per second. Multiply by the time. What is the time? The total time, it is 4473 3, which is 176460 radian. Now he asked us to do it how many revolutions? How many revolutions? So we have to divide all of that over 2 pi. Divide all that, because each revolution is 2 pi. So total angular displacement is equal to this number divided by 2 pi, and it's equal to 8084 revolution. Let me see your questions. Why can't we just use revolution per minute and multiply by time? You can. You can. Of course you can. This is what we did, Saeed, but 2 revolutions. That's correct, because we have initial angular speed and final angular speed. And we need to find the total distance covered. It's exactly like we do it in a linear. طيب, let's do part C. يا عادل.
Okay, Doctor. What is the angular acceleration of the compact disk over the 4.473 seconds time interval?
طيب, what is the angular acceleration? يعني he asked us, تخيلوا زمان انه I give you initial velocity, final velocity, and I ask you for what is the acceleration. It's exactly the same. So here, instead of linear acceleration, I'm asking about angular acceleration. Well, we know that A is equal delta V over delta T. So معناته alpha is equal delta omega over delta T, which means initial final speed minus initial speed over delta time. The final was 22.4. The initial in the innermost يعني 56.5. Well, total time is given for us. So that means the angular acceleration is negative because it is going slower. 7.6, 10 to minus 3. Units is radian per second square. So that is alpha. Very, very easy. يعني it cannot go easier than that. Very easy problems, very easy concepts. We need just to transfer our information from linear to angular using the simple line of the circumference of a circle. X is equal, or circumference, which is x, is equal to 2 pi r. 2 pi is theta, that means x is equal theta r. طيب. الحين let's talk about torque, اللي هو بالعربي إذا ذاكرينه من الثانوية شو كنا نحكيه بالعربي torque. What is torque in Arabic? بالعربي يعني بالتورك شو كنا نحكي له؟ اللي هو العزم. احسنتوا، العزم. تورك اللي هو بالعربي العزم. طيب let's talk about torque. هلا شوفوا in the book He is talking about torque fully as a vector in chapter 11. However, it will be confusing to deal with torque in this chapter as a magnitude only, and after we deal with torque as a vector. So let's deal with torque as a vector and define it as a vector. We will do that in chapter 11, but I found it extremely confusing to deal with torque here just as a magnitude. We will, assuming that we are talking about one dimension or something like that, but let's define torque as in chapter 11. What is torque? Torque, first of all, is a vector. Torque is a vector, and it is a cross product. يعني جماعة الخير انتبهوا. This is cross product. It is not multiplication. Yeah, it is not the multiplication 2 multiplied by 3 or 1 multiplied by whatever. This is a cross product. يعني we have to use matrices to find the vector. It's a cross product between two vectors. In order to calculate it, we need to use a special mathematical tool. It's not multiplication. It's not 5 multiplied by 2 is equal 10. انتبهوا, this is a cross product. We need to use a mathematical tool to calculate it. And we will, inshallah, do that in chapter 11. In chapter 11. But for now, we need to understand that torque is a vector, and it is a cross product between the vector R. What is the vector R? Well, here is our axis of motion. Here is our axis of motion, and R is the vector between the axis of motion and the point where we apply force. That is R. And it's a vector. It's a vector. يعني R is pointing in this direction. It's not pointing in this direction. R is pointing from left to right, not from right to left. It's a vector. It is a vector. طيب يا أستاذ, R cross what? Cross مش الضرب, قلنا كمان مرة, مش الضرب تبع 3 ضرب 4 يساوي 12. لا, it's a tool. It's a cross product between two vectors. The other vector is the force. The other vector is the force. طيب, this is as vectors. وبعدين torque must be perpendicular on both vectors. Torque must be اللي هو cross product R and F. Torque will be perpendicular on both vectors. طيب, let's talk about the magnitude of torque. The magnitude of torque. Well, the magnitude of torque اللي هو torque without a vector. That means this is magnitude. Is equal the magnitude of R, the magnitude of vector R, multiplied by the magnitude of vector F, and here multiply, it's the mathematical multiplication. خلاص, the cross product, it's over, because we are now talking about the value, the magnitude of that vector, and then we multiply by the sign of phi in the drawing here. We will see it. But phi, it's the angle between the vector f and the vector r. That is phi. So here in this drawings, first of all, we don't have theta. This is phi. There is no theta here in the diagram. Phi, it's the angle between the vector r and the vector f and the vector f. طيب تتذكروا لما حكينا على الورك، أنا من باب ذكر الشيء بالشيء، حكينا work is equal F dot D, and we said this is a dot product between two vectors and it will give me just a magnitude, and at that time we said it is F D cosine theta. So if there is a distance, displacement D, and we apply a force F, and here is the distance. So we said, what is the meaning of a cosine theta? That means F cosine theta multiplied by D. يعني we are the only component of the force that will produce work is this component. That is F cosine theta. This component of the force will do work. The other component of the force will not do work, which is parallel in the same direction of the displacement. This is the meaning of the dot product. طيب, what is the meaning of the cross product? Well, the magnitude, we will just repeat. So this is our R. It's a vector. And this is our force, for example. Now the cross product, that means only the perpendicular part of the force will give me torque. Only the perpendicular part of the force will give me torque. So if this is phi, for example, what is F sine phi? It is this component. And this is F sine phi. That means only the perpendicular component of the force, perpendicular to R, will do torque for me. The other component will not do torque for me. Only the component which is perpendicular will produce torque. Other components will not produce torque. So that is the meaning of the magnitude of the cross product. Cross product, that means perpendicular, so we replace it with a sine theta. That means we are talking only on the perpendicular component that will produce torque. طيب, here it's not justified, because if we are dealing with torque as a magnitude, it's not justified. Why, for example, if D is negative. Well, if it is a vector, yes, we know that vectors can be negative, can be positive, but we will just talk about that more in chapter 11, inshallah. What is D in torque? Well, again, he loved that so much, so he defined D as R sine theta, which is, well, look at this. Look at this. This is D. This is D. And this is theta. This is R. What is D? D is R sine theta. D is R sine theta. This is theta. That means this is theta. That means this is afwan. This is to explain for you. This is phi, and this is theta. What is this component? D in reality is equal R cosine theta. Type, what is the relation between theta and phi? Well, they complete each other, so that means R sine phi. So he loved that in the book. He loved that so much. I don't know, just to confuse students, I have no idea. But D is R sine theta. And why we use D? Well, to make the angle between the force, this is the force, and this is D, and the angle is 90 degrees. Again, we return back to only the perpendicular part of the force will result into torque. So instead of finding the perpendicular part of the force, he found the perpendicular part of D. But it is the same. It is the same. I will stick to this definition. It is much easier to understand. Of course. Of course. Dot is parallel, of course. Dot is the component in the same direction of the displacement. Will it cross? No, it's perpendicular. He called it alpha. Well, I don't know, يعني, because he called it alpha in the book. If I use theta, you'll be confused. So he called it alpha, I call it alpha. Phi يا ربي. شكرا. مين هذا يا man? Yes, he call it phi, so I have to use phi in order to avoid confusion. Here I use phi because in the book he used phi. And here I use theta because if I told you D is equal R sine phi, you'll never understand. This is R, the component is cosine theta, but cosine theta is sine phi. Amazing, he's dealing with things in a very hard way, and you can do it much easier. طيب, what's left? Well, we know that F is equal ma, and torque is F dot R. F cross R, but here we are dealing with the magnitude. We are dealing with the magnitude, assuming the angle between F and R is always 90 degrees. Sine 90 is equal 1. So that means the sine disappears from here. Sine 90 is 1, so it disappears. Why is doing that? Well, to reach to this relation. To reach this relation. In other words, and we will see it in chapter 11, torque is a vector. I, we call it moment of inertia, and alpha is a vector. Angular acceleration is a vector. So here he's talking about the magnitude only. but the proper way to write, and we will use this notation in chapter 11 when we talk about torque. Torque is a vector, and I is the moment of inertia, and alpha is a vector. I is the moment of inertia. We'll explain it just in a minute. I is just some constant, and that constant multiplied by the mass and multiplied by r square, or here r square, small r, just to be compatible. And that constant depends on the shape of the object. But we must have mass and we must have r square. The constant is different depending on the object of the shape. The shape of the object of the shape of the object. Here, for example, if we have a hoop or thin cylinder shell, then moment of inertia is mr square. طيب, suppose that we have a solid cylinder, a moment of inertia is half mr square. Suppose we have a hollow cylinder, moment of inertia is equal half m r1 square plus r2 square. طيب, for a rectangle plate, moment of inertia is equal 1 over 12 m a square plus b square, and etc. etc. So if we give you a problem, we will give you the moment of inertia. If you don't need to memorize it, so in a problem we will give you that the moment of inertia of this object is equal to this. طيب, let's do this example with numbers, because God help you, يعني after that he goes into I don't know, just derivation after derivation after derivation. I don't know what is the target. So instead of deriving all those equations, we'll just take numerical example to make things clearer. أيوة يا عادل, اقرأ لنا.
Okay. The uniform mode of length L and mass M is attached to one end to a frictionless pivot and is free to rotate about the pivot in the vertical plane as in the figure. The rod is released from rest in the horizontal position. What are the initial angular acceleration of the rod and the initial translational acceleration? That's right. That's right then.
طيب شوفوا يا جماعة. don't lecture and drive. Don't attend the lecture and drive.
It's physics lecture, I have to.
طيب, هلا شو المسألة? What is our problem? We have a rod. This is a rod, and we have a pivot here, and we let this rod to fall freely. So that means we will have an angular motion. We will have an angular motion because from here it cannot move. So we will have an angular motion. We will have alpha, and of course we will have a linear acceleration. So he asked us for translational acceleration, initial translational acceleration, and initial angular acceleration. تمام? He asks you, or what he will do, he will just find an expression. I mean, in the exam it's useless. You are not going to remember all of this, and you will not memorize how to reach to this. in the exam, barely you have time to solve the problems. So instead of that, we will give a numerical value. So here let's assume in this problem, let's assume L to be 1 meter, and let's assume the mass of the rod is 2 kilogram, and he needs alpha and the tangential acceleration. Yeah, time's up. I know. خلاص we'll stop here. يعني they trap us in this syllabus time. يعني hopefully we can finish. طيب we stop here.
دكتور